Hello, this is Mrs. Dehn-Brastad, and today we're going to talk about Chapter 1, Section 4, which is on different relationships between angles, especially pairs of angles. So we're going to begin with a quick warm-up. So this is meant for you to practice and make sure you know how to solve these. These are some skills that you would need to know to review before doing this lesson. So go ahead, do these on your own paper, pause the video, then come back and check. So for number 1, you should have got 70 minus x, and that's because this minus sign will distribute through the parentheses. I often will tell algebra students to put a 1 here. So you're really taking negative 1 times x, and then negative 1 times 20. So you'd get 90 minus 1x minus 20, and then you can see that 90 minus 20 is 70 minus 1x or minus x. Number 2 is very similar. The minus sign, or the minus 1, will distribute through. And it'll change both of the signs in the parentheses. So we'll end up with 190, because 180 minus a negative 10 will be 190, same as 180 plus 10, and then the minus 3x. For number 4, to write an algebraic expression for 4 more than twice a number, more than means plus, twice a number means 2 times. So 2n plus 4. You don't have to use an n, you can use an x or something like that. And number 4, 6 less than half a number. If you remember correctly, less than, you put that at the back. So 6 less than minus 6 at the end of half of a number. Our objectives for today's lesson are to identify adjacent, vertical, complementary, and supplementary angles, and also to find the measures of pairs of angles. Here's our important terms for today. You'll see there's fewer than the last few sections. Adjacent, linear, complementary, supplementary, and vertical angles. You will use these through the rest of the year. In all of the geometry chapters to follow, or almost all of them, these will come up again. So memorize these, learn them well this chapter. There's a lot of special relationships in angles, and we're going to learn some of these. If you recognize that angles have these special relationships, you can find missing angle measures. Our first two that we're going to look at is adjacent angles. Adjacent angles is when you have two angles in the same plane that have a common vertex. Right here is their common vertex, and they also have a common side. So that ray there is shared between angle 1 and angle 2. So those are called adjacent angles, basically next to each other. And they're touching as well. Those are adjacent. They have a shared side, common side. A linear pair is when you have two angles that add together to equal 180 degrees. Or in this specific definition, it says whose non-common sides are opposite rays. But they add to 180 degrees or a straight line. Straight angle, that is called sometimes too. And they have to be adjacent. So they're adjacent and they add up to 180 degrees. Both parts have to be true. Okay, in this example, we're going to be looking at this figure and see if these given angles are adjacent and a linear pair, or not adjacent at all. Remember, to be a linear pair, they have to be adjacent first. So the first thing is to find these angles. Angle AEB. Now remember, when you name an angle, the vertex is the middle letter. So here's our vertex. The A and the B are on the sides of the angle. So angle AEB is this green one right here. The other angle that we're looking at is BED. Well, same vertex, B, E, D, but this time, this purple one, I'm going to draw it in purple. So did they share a side? They did. They shared side EB. So they're definitely adjacent. Do they also form a linear pair? Did they make 180 degrees when we add them together? They do. So then they are adjacent angles and they form a linear pair. Now let's look at this one. First we have to, is this the same one? Oh no, two different, it's the same drawing, but we're talking about two different angles. So AEB, I've got the purple pen, so here's AEB. And then the other angle, I'll change my color to blue here, BEC. BEC. So if they share a common side, they're adjacent. They do, because I drew the purple and the blue on top of each other. So they're definitely adjacent. Do they form a linear pair? Well, no, because this time they didn't make a straight angle. They're not they can't be not adjacent because we already picked that they're adjacent. So on these ones, you're going to say they're only adjacent. Okay, one more to try. DEC, DEC. There's DEC and AEB, AEB. Now, this time I did not have a common side. They don't touch each other. So they can't be a linear pair because linear pairs always are adjacent. So they're just not adjacent. There's nothing else that they can be because they don't have a common side. All right, so now you're going to try this one. Look at angle 5 and angle 6 and decide whether they are only adjacent, and form a linear pair, or not adjacent at all. And you probably already decided, but here's angle 5 and here's angle 6. They shared a common side, so that means they are adjacent. If they also form a straight line, which they do, then they're a linear pair. So they are adjacent and a linear pair. Okay, here's another one to try. Angle 7 and angle SPU. So find those two angles and decide whether or not they're adjacent, only adjacent and a linear pair, or not adjacent at all. So here's angle 7 and angle, whoops, sorry about that. Where was I? Right there, okay. And then angle SPU is SPU. Here's angle SPU. Now this one's a little tricky. They did share a common side, didn't they? But they don't have, they're not, I don't know how to say it, but they're not next to each other. They're not adjacent. They're like overlapping. So they're not adjacent. They had this vertex here, and they had a side, but it's not a side that is next to each other. It's actually overlapping. So then we have to say that they're not adjacent. Here's angle 7. Here's angle 8. Real quickly decide. And they're not adjacent. That one's easy to tell because they're not touching each other. Okay, two more words for today is complementary and supplementary. You have to know the difference here. You have to memorize which one's which. Complementary is when you have two angles whose measures have a sum of 90. So if you take angle A plus angle B, well actually the measure of angle A plus the measure of angle B, it has to equal 90 degrees. Supplementary is when you add the measures of the two angles up and you get 180 degrees. Some people remember it as supplementary starts with an S, and so does straight line. But they don't have to be adjacent. So in this example, if you just can find two angles that add together to equal 180, even if they're not touching, let's see, 7 plus 3 is 10, 8, 180. So if I added 53 and 127 together, I would get a straight line. So they're supplementary. So if you think about moving angle A down here, move it down here, then you would have a straight line. So supplementary is straight, 180 degrees, complementary is 90. But they don't have to be adjacent. They can be, but they don't have to be. We can use complementary and supplementary. If we know they're complementary or supplementary, we can use a little bit of algebra to find the other angle. So if they're complementary, you can just go 90 minus x to find the other one. If they're supplementary, you can go 180 minus x to find the measure of the other angle. All right, so here we have an angle, 59 degrees, and we want to find its complement. So we want to find the angle so that if we added them together, we would get a 90-degree angle. So to do that, you just go 90 minus 59 degrees, and you will get the measure of its complement. And that would be 31 degrees. For supplementary, we want to find the measure of the angle so that when we add these two angles together, we would get a straight line, or 180 degrees. So 180 minus 7x plus 10, and that's why we did that warm-up problem. We would have to take minus 7x and then minus 10. So 180 minus 7x minus 10, and then we would combine our like terms and get 170 minus 7x degrees. And we would just leave it like that. We can't find an actual number because we have an x in the problem. Okay, here's a couple more for you to try. Find the complement of this one here. So we know that we're going to take 90 minus x. X in this case is the measure, this whole thing. So we plug that in for x. So we'd go 90 minus 7x. Now what? Do I write minus 12? No, because it's really 90 minus, in parentheses, 7x minus 12. So use a parentheses as a way to make sure that you know that you're subtracting that whole thing. And then you can see that's really 90 plus 12. And 90 plus 12 is going to equal 102 minus 7x. Now, it's nice to, if you remember, to put parentheses around that and then put your little degree sign. That really shows that you have degrees that you're ending up with. Letter B is easier because there's no x's in it. There's no algebra to do here. You just take 180 minus 116.5 degrees, and you get your answer of 63.5 or 63.5 degrees. Okay, using complements and supplements to solve problems. That's our next example. These are just little word problems, but they're not bad. Okay, we're going to remember some things here. We're going to remember that when you see an is, it means equals. Okay. We know that for complement, it's going to be 90 minus x. That's complement. And if we see the word supplement, we will use 180 minus x. Let's see, what else do we know? More than means plus. These are algebra skills. The more than and the is. And 3 times will mean times 3. All right. So an angle, we don't know angle, so we're just going to call this x, is, that's an equal sign, 10 degrees more than, so that's going to be 10 plus, 3 times the measure of its complement. So that's going to be 3 times something. So I'm going to put in parentheses the measure of its complement. Well, complement's going to be this, 90 minus x. All right, let's see how we did. All right, they're letting the measure of angle A equal x, and the B, its complement, is 90 minus x. All right, write and solve an equation. X equals 3 times 90 minus x plus 10. Now, what's the difference? The difference is that I put 10 plus, and they put plus 10 at the back. Either way is correct, because addition is, you can do it in any order. You don't have to put the 10 plus, you can put the plus 10 at the back. Either one is correct. And then you solve your equation. We will do the distributive property. 3 times 90 is 270. 3 times x is a minus 3x, and then the plus 10. And then we'll add our like terms. And now I will add 3x to both sides right here. And get 4x equals 280. And then we will divide by 4 to get 70. So now it says find the measure of the complement. In geometry, always go back and see what we're trying to find. A lot of times you'll start by finding x, and then you'll still have to go back and say, wait, what's the complement then? Well, we know complement is 90 minus x. So what do you think the complement's going to be? The complement is going to be 90 minus what we got for x is 70, is equal to 20 degrees. So in this direction, they let angle B be the complement, so I can say that the measure of angle B is 20 degrees. All right, here's one for you to try. Let's see, the angle's measure is 12 degrees more than half the measure of its supplement. All right, angle's measure, let's call that x again. Is our equals. 12 degrees more than is going to be 12 plus half the measure. So that's just going to be 1/2 times something. Measure of its supplement. On the page before, we said that supplement was 180 minus x. So 1/2 of 180 minus x. Let's see if we wrote that correctly. 0.5, well, they changed 1/2 to 0.5, no problem with that. 180 minus x, and again, they put the plus 12 at the back rather than 12 plus like I did. Either way is correct. Then we do the distributive property. 0.5 or half of 180 is 90. 0.5 times negative x or minus x is negative 0.5x, and then the plus 12. And we'll combine our like terms and get x equals 102 minus 0.5x. And then we need to add 0.5x to both sides. So we have 1 plus 0.5 is 1.5. X equals 102. And then we'll divide by 1.5. So x is equal to 68. But that's not what they ask us to find. They ask us to find the measure of the angle. So the measure of the angle is 68 degrees. Oh, see, this one they weren't asking us for the supplement. They were actually asking for x. So if we're letting the angle be x, then you don't have to do another step here. So you have to check carefully at the end. Are they looking for the measure of the angle, or are they looking for the measure of the supplement or the complement, like in the last one? Here's one more example. It says the light passing through a fiber optic cable, this is the cable over here, reflects off the walls of the cable in such a way that angle 1 is congruent to angle 2. So you'll see they already marked these with the little congruent marks. And angle 1 and 3 are complementary. I'm going to draw a little right angle in here, that little square, to remind myself that they're complementary. And angle 2 and 4 are also complementary. If measure of angle 1, let's put that in here, is 47, and then they want you to find measure of angle 2, 3, and 4. Well, how will I find the measure of angle 2? They're congruent. So if they're congruent, their angles are equal. How about the measure of angle 3? Well, these are complementary. 1 and 3 are complementary. So 90 minus 47 is 43, sorry. 43. What do you suppose angle 4 is going to be? Whoops. They're listing this step by step by step by step. We already wrote some of that down. Here's our plan. And then solving. All right, so we get 47 degrees for measure of angle 2. We get 43 degrees for the other two. And then we look back and see that the answer makes sense. Whoops, I didn't mean to go that fast. My keyboard seems to think that we should be at the end here.